Welcome again. In this video, we're going to explore a very powerful conceptual tool when dealing with base 10, or indeed any base, and that has to do with bracketing. And by bracketing, it's a way of helping develop numeracy by comparing relative and proportional sizes of items from various powers of 10. Let's go back and think about the video that we watched where we started with the couple on the park in Chicago and went out by powers of 10 and then back in by powers of 10. This will give you a chance to see what I mean by bracketing. The beginning slide was at 10 to the 0 power, and as you might remember, 10 to the 0 power in terms of meters would be 1 meter. And that's roughly the distance between your nose and the tips of your fingers. It's also a little bit over a yard for those of us who grew up in the English system rather than the far more sensible metric system. So what we see in this particular slide then would be things that are within 1 meter, what we could reach out and touch. Now I'm going to select a little bit larger power of 10 now for us for our bracketing purposes, and that is 7 powers of 10. So we're going to be comparing now 10 to the 0 power and 10 to the 7th power. When we look at 10 to the 7th power, what we see is we see that our field of vision has expanded now to include the entire Earth in that box. So if we are at 10 to the 0 power, the world we're familiar with, at 10 to the 7th power, that's the size of the entire Earth. As we jump up another power of 10, we go to 10 to the 14th power. And it's kind of hard to see in this screenshot, but if you look in the center, that is the solar system. The inner and the outer planets. If you count the Oort cloud, oddly enough, that is 10 to the 14th power. And since the Oort cloud is classed as part of our solar system, I think it's fair to say that 10 to the 14th power would include our solar system, including the outer comets and the Oort cloud. Now, what's interesting about this is that we are, relative to the size of the Earth, the same as the Earth is relative to the solar system. Now, for those of you who may have traveled a little bit, we have kind of a feel for what the Earth is, about how big it is. And I don't think we really have the same feel for how much larger the solar system is than the Earth. We literally are the same in proportion to the size of the Earth as the Earth is to the size of the solar system. If we now bracket to 10 to the 21st power, you will notice that what we are seeing is we are seeing the entire Milky Way galaxy in that central box. So the Milky Way galaxy is as large compared to our solar system as our solar system is compared to the size of the Earth, as the size of the Earth is compared to the 2 picnickers on the park. Going smaller, when we look at 10 to the minus 7th power, we see DNA in the box. So our DNA is as small relative to us as we are relative to the entire Earth. I don't know about you, but I've always found that kind of an amazing thing. I'm used to thinking about larger powers of 10, but when I start looking at smaller powers of 10, I never cease to be surprised. At 10 to the minus 14th, we are now at the proton-neutron level, the nucleus of an atom. So the atom is as small compared to DNA as DNA is compared to us, as we are compared to the Earth, as the Earth is compared to the solar system, and as the solar system is compared to the Milky Way galaxy. This technique of bracketing can be extremely powerful in trying to help students get a notion of relative sizes of things. For example, it's not uncommon for students to misalign digits in multiplication, with the result that their answers can be off by a couple powers of 10. An easy way to help students come with this, to realize they've made a mistake, is to say, oh my goodness, look what's happened. You meant to say 100 and instead you said 10. Quite often, especially third graders, they will say, well, that's close enough. And you can respond at this point by saying, well, which would you rather do, run 10 yards or the entire length of a football field? I know personally I would rather run the 10 yards. Bracketing can be an extremely powerful tool, and so I'm going to have you explore this a little bit further. One of our exploration tools for this week's assignment is Powers of 10. It's a website I'm going to have you visit, and I'd like you to spend some serious time exploring it. In order to get to this website, if you go to your Blackboard shell and open up our week 4, within week 4, one of the links will be Powers of 10. You will also notice that I have given you the instructions here as well, so they're repeated. Once you click on the link, it'll open up a language selection screen. I will select US English, and it'll give you the opportunity to open the actual application over here under Start. Once you get into the website itself, it plays some music that you can turn off or turn on if you'd like. But what's quite interesting is I can now scroll out by powers of 10. I can scroll in by powers of 10. It's very, very similar to the movie we watched earlier, except it gives us a great deal more control. The other thing you will notice as you explore this is the number of powers of 10 that's been increased to our understanding. You can zoom in, you can zoom out, you can compare relative sizes. You will notice when you compare this with the video that we watched in class that we have picked up quite a few powers of 10, mostly on the small end of the universe, on getting smaller and smaller. So a lot of things to explore. Then I'm going to have you apply your bracketing skills through a series of prompts where you'll start at one situation and then explore 3 powers of 10 larger and 3 powers of 10 smaller. If you read the instructions for this assignment, it should be relatively clear. Please feel free to contact me, however, if you have any questions. I believe you will find that bracketing is going to be an excellent tool for you to use in teaching to help young people expand their notions of numeracy into both extremely large and extremely small numbers, thanks to our old friends subitizing, chunking, powers of 10, base, exponent, and place value. And I hope you're becoming much more comfortable with these ideas as a result of your reading, your exploration, and your discussions.